So our next session, which is actually a new SNIA tutorial where we're kind of excited about presenting here, fog computing and its ecosystem. The speaker is Ramin, Elahi, who's an adjunct professor and advisory board member at the UC Santa Cruz, Silicon Valley. He's taught data center storage, Unix networking, and system administration at UC Santa Cruz and UC Berkeley Extension since 1996. He's also a senior education consultant at EMC Corporation. Ramin?
Okay, good afternoon and Happy New Year. Thank you, Michael, for the intro. What a great way to start 2016 with yet another Storage Vision and SNIA conference here in lovely Vegas. And thanks for your interest in this topic, fog computing and its ecosystem. Before we start, we need to go over these SNIA legal notices. The contents is copyrighted by SNIA, and the usage of any of these contents is free as long as it's properly cited and sourced. Kind of a wordy abstract, but what it is, what fog computing it is the extension of cloud computing, and it's try to brings the compute, storage, networking, and business application closer to the end nodes, and particularly with the in relationship to the Internet of Things. There are some challenges facing the cloud computing as far as lack of bandwidth, very high latency, and also the high cost of transporting data to the cloud. So fog is a new concept, and it's proposing some benefits to deal with the current, addressing some of the current challenges that the cloud computing has. As far as the agenda, I just want to ask you to join me in the journey coming down from the cloud all the way down to the fog, closer to the end users. And we'll try to talk about give you some preview on the cloud computing, cloud. I know we are all familiar with it, but for the flow of this presentation, how the cloud transition to Internet of Things and to Internet of Everything with billions and billions devices connecting to this global network, and provide some general awareness about fog computing. And one of the things that I want to emphasize with this presentation is fog is not here to replace nor make cloud computing obsolete. In fact, it's an extension of it. It's going to supplement and complement cloud computing. And we are going to be, at the end, talk about comparing and contrasting fog with the cloud. And at the end, hopefully we have enough time to do a Q&A session. Every one of us in the room, part of this storage industry, are pretty much aware of these major trends. They are major trends because over the past few years, lots of investments and resources have been poured into these technologies and some of their derivatives. As for amongst these technologies, cloud, analytics, big data, and mobility are very relevant to our discussion of fog computing today. Also, we have been witnessing a very rapid data growth in our data centers, and the major culprit behind the increase in hardware components, number of the amount of the data, increase in the virtual machine, is nothing but the unstructured data being generated from a variety of sources like social media, videos, and business applications on the cloud. And many businesses came to acknowledge the fact that they no longer can afford hosting all of the data resources on their own premises. So what they did over the past decade, they tried to offload, send many of these resources onto the cloud. And we are the beneficiary of the cloud, users of the cloud, both at the corporate level as well as in the personal level. And because of these business and technical characteristics that cloud has become a propitious method for achieving performance and scale while maximizing the ROI and increased flexibility. And over the years, different types of cloud have been developed. You're all familiar with private cloud, let's say somebody's premises, somebody's company premises, all the way to the public cloud and stuff in between as a hybrid. Also, different vendors over the years are trying to provide some sort of a services, cloud services, from just providing a business application, software on the cloud, all the way to provide the whole 9 yards, the entire data center, infrastructure, network, and software development platform, and selling them as, offering them as a service. And every day that we wake up, hey, there is a new type of a service now available on the cloud. But these are some of the predominant types of services being offered by various vendors on the cloud. Over the past few years, we also witnessed that more and more devices are connecting to the cloud. Beside the legacy devices like a laptop, desktop, smartphones, we'll see that more and more devices in the sense of sensors, engines, telemetrics, wearables are connected to the cloud, and also our pets and cattle are the things that having some sort of an interface to connect to the cloud, and that is called Internet of Things. And this is a interesting slide and some interesting numbers. Back into with relationship with the number of the population of the world and the number of the connected devices to the network. Back in 2003, only with the population of 8.3 billion Earth, we had only 500 million devices, not in a billion, 500 million connected devices. And that were only primarily our servers, our computers, and some smartphones. And in a matter of 6-7 years, the numbers jacked up to be in billions. So in 2010, with a population of 6.8 billion, over 12.5 billion. So in a matter of 6 years, from 500 million, number of the devices jumped to 2.5 billion. And what companies like Cisco are anticipating is that in 2020, the number of the connected devices will be about 50 billion devices. So 50 billion objects, while the world population will be around 7.8 billion. And that would tell you that each person would have at least 6 devices that is connecting to the network. would be the laptops, smartphones, wearables, and perhaps pets and cattle. And by adding all of these more and more devices, these things would be practically everything. That's another step is milestone would be Internet of Everything. And the main 4 pillars of Internet of Everything would be data, things, people, and processes. So as far as the data, the exuberant amount of the data that these devices, objects are going to produce, and there has to be a way that we can find the relevant data that would have some meaning to us. Also the things, these would be the things that eventually going to be connecting, and those would be the legacy devices, wearables, and other items. People, how can we find a better way to connect all these people? And with the processes, there should be a way that we can funnel and send the right information, retrieve the right information, and funnel and channel the relevant information to the right people. Again, we're talking about eventually about billions and billions of devices, and finding the right way to get the right information to people would be very important. And of course, with the cloud today, the way it is even today, with all the billions of devices that are connected to it, in the terms of computers, smartphones, sensors, plane engines, etc. We have these major challenges. Too much data. Nobody can deny that. Given the fact that, a majority of these data being generated by these various sources are trivial. But still, we have to process it, just like the junk mails. When the junk mails arrive, post offices have to deal with it. And the mailman has to deal with it until that it comes to our mailbox, and then we'll toss it away. So still, all this data has to be processed, analyzed, and there should be some storage provision for it. Resiliency. Well, it would be very difficult to implement resiliency, high availability for all these billions and billions of end nodes. In the cloud model, latency and how far is it away from the end nodes is creating problem because of too much propagation delay. And usually the end nodes are very far removed. They have to go through so many networks, hubs, to get to the servers in the cloud. So sometimes the real-time processing would not be would be available. And last but not least, the exuberant cost of transporting data. With billions and billions of devices, are we going to have a dedicated T1 line, dedicated leased line for connecting each of these nodes to the cloud? So these are some of the major challenges that are facing the cloud with more and more devices connecting to it. We are living in the digitized world. All of our data are being digitized, both at the personal level, at the corporate level. Back in 2014, amount of the digitized data was about 3.4 zettabyte, and zettabyte is, by the way, is what, 10 to the power of 21. So you have your terabytes, petabytes, exabytes, 10 to the power of 18, and zettabytes, 10 to the power of 21. And in a matter of a few years, it would be over 10 zettabytes. Amount of the traffic inside of our data center is going to be tripled. And the communication between the data centers are going to be 31% growth, and 37% of traffic needs to be done closer to the end nodes, to the devices. And we have to come to think about the fact that whether or not our current way of doing storage, compute, and analytics, would it still be valid, the right way to do, considering that much data within our data centers. And for that, the idea of fog, here's is a fog, also known as edge computing in the industry. Here's a definition of it. I'll go ahead and pause, and I'll go ahead and continue on, just give you a chance to read this definition.
Is fog an emerging term?
Pardon me?
Fog is the emerging term?
Yeah, fog is a emerging term in relationship to cloud. It's not an acronym. It's just that it sits closer to the end node, just like fog is closer to the ground versus cloud very far removed in skies. So with fog, as you can see it in the definition, the idea is to take the resources of compute and storage closer to the end nodes, particularly when you are going to have more and more devices try to communicate with some sort of a data center. And as I mentioned in the beginning, fog is not a replacement, nor is going to make cloud obsolete. It will only enhance, supplement, and complement our current cloud computing, making the data centers more successful. And these are some of the characteristics of fog that, as you can see, that will address some of the challenges that we talked about facing current cloud computing. Because it's closer to the end nodes, it's only a few or one hop away from the end node, so the latency would be much shorter. Since it can communicate with the relevant end nodes, it can go ahead and retrieve, gather the right information, right data in order to send it upstairs to the cloud. Also, one of the things today, one of the challenges with the big data today is the 3 V's, velocity, variety, and the volume of the data that is keep flowing in. So fog computing would be excellent way to deal with these 3 V's, and also can help us better with the real-time processing and analytics. And since lots of these nodes today, objects going forward are considered going to be mobile devices, fog would be very more efficient to deal with the mobile devices. This is a very overview, simplistic way of illustrating the fog architecture. So as you can see at the end nodes, each of the end nodes have a very, very limited and short amount of the computing resources and storage. And that's a cloud with infinite compute and storage resources. And by inserting these middle layers, these form of the cloud nodes, then we can have, the end nodes can enjoy much shorter latency and be able to have some of their needs, data be computed, stored at this level, rather than spending a lot of money and efforts sending it upstairs to the cloud. This point has been risen by many folks that, well, this fog computing is nothing new. It's pretty much similar to existing client-server model or distributed processing, etc. Of course, there are a lot of similarities. There are a lot of analogies that can be drawn. But one of the main differentiator with fog and dealing with the end nodes is that the fog nodes are positions us better to deal with this Internet of Things, when the end nodes are going to be in billions and billions. There are a lot of a mechanism, as we are going to see in the future slides, that are using some virtual benefits technologies as far as load distribution, quality of the service, multi-tenancies that these fog and intermediary nodes can provide, that perhaps not really available in the client-server model. With this slide, again, trying to show the at each end we have the our end nodes with some sort of an interface to the network, and on top sits our data center in some sort of a cloud, and in between we have these fog nodes, and these fog nodes can be virtual, can be physical, and the beauties of these fog nodes, each covering a certain geographic location, they're all communicating with each other in the east-west, north-south manner. And as I said earlier, the characteristics of each of these fogs, they can provide quality service, multi-tenancy. And what am I going with this slide is that, let's say that if we don't have these fog nodes, what would happen that if you try to make these current cloud computing more efficient by creating more or inserting more intelligence on the top? So if you are trying to push the intelligence up toward the cloud, then you still cannot deny the latency. Still, latency would be there because it's very far from the end nodes. That geographical diversity and the large coverage, and then the network bandwidth and reliability also going to issues also going to be there, and with that many nodes, the analytics and processing this data in real time still going to be an issue. By introducing those nodes, those fog nodes in the middle, well, we can go ahead and address that. So we don't need to beef up the intelligence on the top inside of the cloud. By inserting those fog nodes, well, there would be less networks. It would be probably, each of these fog nodes would be one hop away from the end nodes. Therefore, your latency would drop, and you can go ahead and provide more intelligence at the lower tier, and you can implement better security, and also do some analytics and processing more real time. Yes, sir.
So are you saying that fog computing gives us greater inherent security, or are you saying it gives us an opportunity to add security? I wasn't sure.
Probably both, or probably I can add that it provides more granular security, because you probably don't need to, I mean, if you want to make all of these billions and billions of devices secure, you have to put them all on the cloud, on the servers. And what would happen that if all of these are getting compromised? All of these 50 billion devices, security going to be compromised. Whereas if you do granular or regional or subset of it on each fault node, when those are not very immune either. So probably subset of that data, if it's getting compromised.
All right.
So
I'll ask you again later.
Okay, sure, yeah. Yeah,
I
go
have a
ahead.
quick comment as well. I think this speaks to a different way of viewing all these resources.
Sure.
In other words, tier it, you could prioritize it. You could say, we're gonna handle this at this level, we're not gonna let it percolate all the way up, or we're going to gather and aggregate things. There's so many decisions to be made between your levels, I don't think we have to view it as homogeneous.
Exactly. And another option would be that what would happen if we, without doing a fog, if we go ahead and try to push down the intelligence down to the end nodes. So in a simple way, that would be, do we want to have all of the nodes to be a smartphone, as a smartphone? With 50 billion devices or billions of devices, it would not be very cost effective, it would be very difficult to do. Why? Because each of these end nodes, sensors, engines, or beds and cattles, or the wearables, they have some sort of a physical as well as some functional constraints that you really cannot build more computational power, storage, so on and so forth. And it would be very difficult that, again, implement security to each one of those nodes. And that's why with fog, if we put them insert them between the end nodes and the cloud, yeah, basically that these fog nodes are more equipped, has more storage and compute resources. Again, probably on those, they have a better operating system that you can implement the security, and you can also build more redundancy and high availability. So this is what eventually it's going to look like, at least on the paper, that you still have your infinite resources as far as the storage and compute and analytics in the cloud, but closer to these nodes, you have these fog nodes that are trying to address what we just talked about and deal with the challenges facing the cloud today: latency, bandwidth, reliability, and the high cost of the transport to the cloud. How one of these fog node would look like? So if you want to go a little bit more, getting more technical and granular look inside of one of these nodes, there have been many implementations of one of these fogs, and this is a research done by researchers in William and Mary College, and they implemented this blueprint as their one of those fog computing platform. Fortunately, don't have time to go to talk about every one of these components, but some of the what we can point into, that it is a bunch of a virtual machine over a hypervisor, and some of the components of this hypervisor is you need to worry about authentication and authorization. That who is allowed, which nodes, which users are allowed to get to this fog node. Also on the local services, all of these fog nodes have to be communicating with each other. All right, so that's another component that needs to be there. Also, you have the cloud agent. For example, if our cloud provider is Amazon, and we are using the Amazon EC2, Amazon Elastic Cloud and Compute. What kind of how can this fog node interact with that cloud on behalf of the clients? So, for example, over here for block storage, probably we need to have a OpenStack sender loaded here. For example, for doing in order to do compute, probably we can do OpenStack Nova component loaded here for computation. For management, we can go ahead and use the Keystone as one of the OpenStack components to work with the cloud. And also, you need to have a bunch of API, for example, for the virtual migration. What would happen that if you have a end user, which is a mobile device, is connecting to one node, to one fog node, and now it changes geography and is moving to another location, to another area. That node doesn't need to start all over again. Its profile has to be migrated from one fog node to another. All right? So that's some of the pieces that you need on any fog computing platform. And there are many different ways that you can implement these fog nodes. This is what is being proposed by, again, researchers at William and Mary College. And the source of this article is given in this presentation if you are interested to study it further. A more overview, we have of a fog, for example, we have the device, the local that does a local data collection, and there is a operating system proposed by one of the companies heavily involved inside of the with the fog computing, like Cisco. They are proposing a operating system like IOX, which does local data analysis and filtering closer to the device and send whatever it cannot, send it to the servers in storage inside of the cloud. So this is one, at a glance, very overview of how it can be implemented. And with respect to big data, we talked about earlier that from a variety of different sources, we have to deal with the 3 V's, volume of the data, variety of the data, as well as the velocity of the data. And with the current model, if we want to go ahead and send all this, I mean, this explosion of data and go to the cloud, it would be very difficult. And we are still going to be facing those issues and problems. And when these numbers grew to be billions and billions in a matter of a few years, you definitely need to have some intermediary, some sort of a fault nodes closer to these devices that at least be able to intercept some of the data, deal with it locally, and for further analysis, resources and storage, send it to the cloud. These are what the customers need as far as storage and compute. Obviously, everybody needs storage and compute within their own premises, and also for reliability and high availability and mission critical, they need the same amount of the resources and storage at their non-production sites, at their DR site, and also many of the customers, many of the companies that would like to have the same amount of the resources at their client, at their customer's site. Okay, and while they want to have all these, they wanted to have a much lower energy bill and less power and more simplified configuration of it. And based on a survey from IDC, their survey said that 40% of all the processing and computation is going to be taking place closer to the end nodes rather than done far from the end nodes at the servers inside of the data centers. And these 2 slides, the table here is to pretty much do a compare and contrast pound per pound. What are the requirements and what are the ways that cloud computing and fog computing are addressing those requirements. So one of the area would be latency. So definitely with fog, with the less number of the networks, latency would be lower. As far as the location of the servers, usually you have different servers again on the cloud globally in the mirror sites, but with the fog, they are all at the edge, closer to the nodes. Because of the latency is low, because the end nodes are only one hop away from the processing unit or storage unit than in the cloud. Again, it's don't want to open up the can of worms, but with the security, yeah, it could basically provided a different tiers. So again, there are a lot of ways, pros and cons of doing security. Again, there's not one single way that would take care of all the security issues. There's no silver bullet. There are some pros and cons, and seems like with fog, it can be more granular and defined and customized when we have limited number of nodes, rather than dealing with the entire devices connected to internet. Location awareness, yeah, definitely with the cloud computing, they have no idea that where the end nodes are at. With fog you have, so you can deal with that. Also, number of the servers in the for the cloud computing, there are few, but with the fog nodes, it would be more nodes because they are covering more geographic areas. With the support of mobility, mobile devices with the cloud, yeah, we're still using it, but probably when it gets to the billions and billions of devices, probably with fog, we can have a better job. And more important thing would be the real-time interactions. Today with in cloud, some of the applications, particularly gaming applications that require very fast and real-time responses, may not be available, may not be feasible doing it with the cloud model, whereas the latency is much shorter. With a higher bandwidth, we can do it. We can achieve it with the fog computing. And the last mile connectivity, you still need to be in the last mile. The nodes have to be some sort of there should be some sort of a dedicated leased line. Whereas in the case of the fog node, probably we can go wireless. One of the, we mentioned that the fog computing is infancy. It's been only a few years that fog have been introduced as an extension, as a complementary resource to cloud. But just this November, the Open Fog Consortium was founded by these industry and educational heavyweights. And this is the mission statement, and anytime you have these kind of an open consortium, it takes the proprietary closeness out of the picture, meaning that more companies, more researchers, more users can be benefited, and contribution would be higher towards the goal of this technology. So that's been a major milestone, and just past November, this forum was formed. So what is next for fog computing? Definitely much better use cases where fog can provide some impacts and some advantages, and how it can help businesses. Also, many of the views that we are proposing and we have today about fog still probably are not perfect. Everything is line in the sand. So we have to, probably perhaps some of our views have to be, and the fog architecture have to be refined. Better application architecture that provides interoperability and application migrations, because you are going to have so many of these fog nodes serving certain number of the nodes in some geographic area. And as we saw in one of the earlier slides, many of these fog nodes may be manufactured by different vendors. There has to be some sort of interoperability between them. And last but not least, we need to make sure that edge and fog computing are only going to make our core data centers inside of the cloud more stronger and successful. And with that, I want to thank you all for your attention and interest in this topic. I hope that I see you again in another SNIA and Storage Vision sponsored conferences, and happy 2016 to all of you. Thank you.